Hey, this is the review for our last test of the semester, and it's not just a conics review, it's a Unit 4 review, and it starts off with the conics and then it ends with the rational functions. So what we're going to do first is we're going to look at this a little bit different from our packet in the fact that it doesn't state what conic that you're going to be working on. You could either look at the first two terms, which are the square terms, and evaluate and say which conic do I know has a positive and negative square term, and your answer should be that would be um, a hyperbola. And then some giveaways are these information down below, where transverse axis and conjugate axis. So the first thing I'm going to do is I'm going to get this into standard form by completing the square. And I'm going to do that by starting with my x. And notice that I've got to factor out the 9. And I notice that I have the x's are right here. And 9 times 6 is 54 because I have to make it a positive 1x squared. And I'm going to take half of 6, which is 3, square it and put 9. And I've successfully completed the square on the x. Next thing that I'm going to do is I'm going to move to my y's. And notice on a hyperbola, no matter what, I have got to at least factor out the negative sign, but this one also has a 16. So I'm going to factor out a negative 16. So I get a positive y squared. And I'm going to factor that out of 48, which is going to be a positive 3. And then that one's not very nice because it's going to be half of 3 is 3 halves squared is 9/4. And then I'm going to bring my 99 over to the other side. It's negative, so it becomes positive. And then I've got to remember to add my number over that I added, complete the square, which was 9, but I had a multiplier of 9, so that becomes 81. And then I'm going to move to my other, and I'm going to take negative 16, and I'm going to multiply it by 9/4, and I end up getting negative 36. Makes me feel pretty good about, got to color that one over here. And now I'm ready just to complete the square. X minus 3 squared minus 16, y plus 3 halves squared. And now I'm going to add up my 99 plus 81 and subtract my 36. And I get 144. And then I'm going to divide everything by 144 because I know a hyperbola is equal to 1, just like an ellipse. And then I know I did it right when these are evenly divisible, right? I can't have a 9 in front of my parentheses of x minus 3 squared. So I'm going to assume that 144 divided by 9 is an even number, which it is. Nice, 16. Then I'm going to do the same thing over here. And we know, well, we just did this. 116 divided by 144, or 144 divided by 16. How about that? Is 9. And those are nice. They're both perfect square roots. And so you might want to square root them and write, this gets me 4. This is going to be my distance of 9. And I'm just going to fill out my information in my spots. Remember that I'm graphing a hyperbola. And so this hyperbola is opening left to right because my x term is coming first. If it was the y term coming first because my x was negative, then it would open up or down. So I know the center of this is 3 comma negative 3 over 2, which is 3 comma negative 5. Okay, so the next thing that I'm going to do is I could do the transverse axis if I wanted to, since this opens left to right. I know I'm from the center, I'm going to go 4 to the left and 4 to the right, which would be 8. I know the conjugate axis is the other way, so I'll go up and down 3, so the distance of 6. And so I'm going to go ahead and graph this now at this point. 1, 2, 3, and negative, what, 1.5? Right about there. Okay. Next thing that I want to do is travel my distances. So I'm going to travel left 4, 1, 2, 3, 4, and right 4, 1, 2, 3, 4. And those would be my vertices because my parabolas are going to open left to right. And then I go up 3, 1, 2, 3, and down 3, 1, 2, 3. And those would be my co-vertices, which doesn't really matter on this one. And then I'm going to draw from my vertices, draw my box. And those are going to give me my asymptotes that go through the corner and through the center and enable me to draw my 2 parabolas. And now I'm ready to say what my vertices are. I've got 2 of them. Looks like -1, -3.5. My other one is what, 1, 2, 3, 4, 5, 6, 7. And the next thing I want to do, I could put my asymptotes on here. So it's my rise over my run. So I went up 3 units and I went right 4 units. So 3 over 4. And now I just need to find my foci. These are the points. So I'm going to write on a hyperbola, we sum together my denominators. And that gives me the length. So I'm going to go 5, 1, 2, 3, 4, 5. That's 1 focus. And then from the center, 1, 2, 3, 4, 5. And so the only difference between my focus and my vertices is that I went 1 more unit beyond. And there is my hyperbola. Okay, next I'm going to move on to my next conic. I don't know what it is. So let's investigate. And I'm going to look at my squared terms and I only see 1 squared term. This must be a parabola. I could also look down at the keywords like vertex, focus, directoric, axis of symmetry, parabola. Okay, so I'm going to collect my squared terms and I'm going to complete the square. I'm going to move my x term over to the other side and my constant term, and I'm just going to complete this square. Oop, where's my x term? And I'm going to complete the square. Half of 8 is 4, squared is 16, so I get a y is 4 squared. Now remember, the other variable that's all by itself is going to be the one that we solve for. So I'm going to add my 40 over. And then I'm going to divide everything by -12 to get x by itself. Oh, let me fast forward. Let me fast forward. I forgot to add 16 to this side, right? So, I mean, rewind, not fast forward. So I noticed something wasn't working out really well. So I have -40, and then I have that plus 16, and I have -24. Much better. notice I was going to get a fraction for my other shift. So I'm going to add my 24 over, and I get negative 12x. Now when I divide by negative 12, get something better. Okay, so I have x equals, and I have a negative 1/12 y plus 4 squared, and then this becomes negative 2. Okay, so if I wanted to find my vertex, remember, this is the one that is going to be opens left because my x is by itself. It's going to be left or right. And since it's negative a, my a is less than 0, it's going to go in the left direction. And so I know my vertex is written kind of backwards in here. This goes with the y value of the vertex, which is in the argument, so opposite sign. And this one is my x value, which is not in the argument, stays the same. So negative 2, negative 4. So I'm going to put that on there. Negative 2, 1, 2, 3, 4. And notice the next two questions. Well, I know it opens left and right. So this could be my axis of symmetry, which is 1, 2, 3, 4, y equals negative 4. And my other two questions are my focus and directoric, which are found by finding c is equal to 1 over the absolute value of a, that distance from the vertex to the focus and directoric. So I know what my a is. My a is 1, and I get, when I multiply those together, I get 4/12, which is a third. I will reciprocate that and get 3. Okay. And that is my distance to my focus and directoric. So I'm going to go 1, 2, 3. This is going to be my directoric because this opens to the left. The focus is always inside the arm. So this is x equals 1. And I'm going to go from the vertex, I'm going to go 1, 2, 3. I know this is my focus, which is 1, 2, 3, 4, 5. Negative 5, negative 4. And now I want to just graph my parabola. So it's been horizontally compressed by 12. So that means if I went to the right one, I would go normally up 1, but I'm just going at 12th. And the next one I'd just be going to 6, so a little bit more. So you get the picture. It's like a really wide parabola like that. And then I'm done. Okay, my next one. I'm going to have to take a look at my squared terms to determine what it is. Well, these have both squared terms, so I know it's a circle, a hyperbola, or an ellipse. It's not a hyperbola because neither one of them are negative. It's not a circle because they're not the exact same two numbers. So this one's got to be an ellipse. And I'm going to need to complete the square. Plus, ellipse has like this major axis and minor axis deal down here, and it also has a center. And so I'm going to start with my x because it always comes first. I'm going to factor out that 16, but there's not the x term with it. So it's just going to remain 16x squared. This one only got to, looks like, complete the square once. So I'm going to pull out my 36 for my y squared, and I get 10. Half of 10 is 5. 5 squared is 25. And that's going to equal negative 324 once it's subtracted over. So I know whatever number I put in there has got to be bigger than negative 324. So I have 25 and I have the multiplier of 36, which gets me 900. And I'm going to subtract from that 324, which gets me 76. And now I'm going to divide everything by 576. And this is my moment to see if I did everything correct, because 576 should be evenly divisible by 16, which it is, and it comes out to 36, which makes me feel especially good because 36 is a perfect square root. And then I'm going to take 576 and I'm going to divide it by 36. And I get 16, which I should have known from the previous division. But anyways, so I feel like I did everything right. Everything turned out nice. So I know I'm going to be traveling the x direction 6 units, that's the square root, and 4 units in the y. And my center is going to be 0, -5. And now I just need to travel, what, 6 units in the x? 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So I know my vertices are those because this is my major axis, definitely the longest. And so those are going to be what? -6, -5, and +6, -5. And now I'm going to travel up 4. 1, 2, 3, 4, and down 4. 1, 2, 3, 4. And so those co-vertices are going to be 0, -1, and 0, -9. The length of my major axis is 12 and my minor axis is 8. I could even put my little oval in there. And now I just need to find the focus, and those are found by subtracting my two denominators. So C is found by 36 minus 16, which is equal to square root of 20, which is approximately, I think 4.5. We did this before. Oh, yep. Okay, so I'm going to go 1, 2, 3, 4.5. 1, 2, 3, 4.5. And if I wanted to give those as points, it would be my x value. I went 4.5, or what is this? 2 square roots of 5. I went 2 square roots of 5 to the right. And I'm still at the -5. And I went -2 square roots of 5 over negative. Okay, and there is my ellipse. So what do we have next? The easy peasy circle. Notice it's both squared terms and they're the same coefficient, both +1. Both of these I've got to complete the square. I love that they're both +1 too because I'm breaking the square here. Both of these without factoring anything out. And I added a 4 and I added a 9. And I get what, 7/16. Remember, this one doesn't equal 1. That's the radius squared. So it's nice that it's 16. And I have x minus 2 squared plus y plus 3 squared. So I have a center of 2, -3, and radius of 4. Oh, place for that. Circle is really easy. So 2, 1, 2, 3. The only common mistake I see sometimes is 1, 2, 3, 4. Some people divide and get the radius to 1 every time because we're so used to an ellipse and a hyperbola, everything being equal to 1. Okay, and we're done my conic section. Make sure you can graph each one of those by completing the square. Okay, next is rational function, and you'll have one of these big old graphing ones. And you'll just have to, do your delta math. Step 1, factor. Keep harping on that delta math because it really helps you figure out what I'm doing here. So the first thing we talked about was factor, 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 because when you factor and you reduce, you have a whole. Whoop, back check that. Here's my reduction. And so when a point of discontinuity factors out, then it's a whole. So the point of discontinuity is -3 because that's that factor if x was 3. That's what give me a 0. So I know my point of discontinuity is x can't equal -3, and then I have a positive 3 in the bottom. So notice the whole is what cancels out. Now, if I have still when I reduce it, if I still have a point of discontinuity in my denominator, which I do, if it doesn't reduce out, it's still a vertical asymptote. I have a vertical asymptote at 3. Okay. So everything I have identified what my points of discontinuity are. I can't plug in -3 or 3. Those cause a 0 in my denominator. I found out that the factor that's associated with the -3 reduced out of the function, so that produces a hole in my graph. And I noticed the factor that created the point of discontinuity that was 3 that was created by the factor x minus 3 never canceled out of my function. And so that point of discontinuity is a vertical asymptote. Only thing left to do is a hole requires 2 parts, an x and a y, so I can locate where it is on the graph. And so I go to the reduced form, and I'm going to plug in the x value that is the hole, which is -3. And now when I plug it in, it won't cause me to be 0 since it canceled out. And I'm left with -1 over -6, which is 1/6. Okay. My domain is easy. It's just excluding anything that caused my denominator to be 0, which are my points of discontinuity. My y-intercept is just, remember, once your function reduces, if it does, you are from then on just going to go to your reduced form. It's a lot easier. So if my x's are 0, I would be left with -2/3. That's my y-intercept. X is 0, I have -2/3. My x-intercepts are the zeros of my numerator once it's reduced. Notice if I try to do my numerator zeros off the bottom, I would have found that I had an x-intercept at -3, but can't because one is continuity. But now that I've reduced it, that's when I go back and look, do I have any x factors left in the numerator? And I said, yeah, I have when x is -2. And if I plugged a -2, right, into the reduced form, I'd have -2 plus 2 over -2 minus 3. I have 0 of -5. That would be my function outputting a 0, which is a x-intercept by definition. So when x is -2, my y is 0. There we go. Now that I've got all this work done, I'm ready, want to go to my graph, and let's put all this information in that we've just found. We've got 4 points and 2 points of discontinuity. We can actually 1, 2, 3 points and 1 vertical asymptote. So let's put our x-intercept of -2 in there. Let's also put in our y-intercept of 0, -2/3. And what else can we do? -2. Oh, and I have a hole at -3, 1/6. 1, 2, 3, open just. That's a doesn't even look like a hole. Okay, and look, those 3 points are kind of like it's like doing something like that, right? So I kind of feel nice about the placement. We'll investigate later. And then I have a vertical asymptote at 3. All right. Now I want to know, where's my graph? What does my graph do around this vertical asymptote? Is it down here or down here, or is it up here or up here? I don't know how my graph is going to approach this vertical asymptote, but it's going to do two of those 4 things. So let's investigate. Let's put this vertical asymptote right on this x-axis line, and here is x equals 3, and I'm going to pick a point real, real, real close. So I'm using 3.001 to the right and 2.999 to make that 1000 multiplier, right? And so reduced form. Look at the original, right? If I'm using this and I'm going to plug in 3.001, look at the original. I have x squared plus 5x. That's awful. The reduced form, right? I have this nice function, much simpler. Use it from now on. All right, so if I plug in 3.001, all I care is I'm going to get some positive number, and I'm going to get positive 0.001. When I multiply a positive number by 1,000, then that means it's going to be a really large Y. That means it's going up. Do the same thing on the other one. If I plug in 2.999, I just know in the top that will give me some bottom number and negative 0.001. So I'm going to multiply by a negative 1,000, which is going to say when I'm really close on the left side, I'm going to be going down. So it looks like when I'm really close on the left side, my down wins out, which matches up with those 3 points. And on the right side, I'm going up because when I'm really close, my Y, when I'm at 3.001, my Y was way up here at like 5,000. So I know my graph is going to approach it. Tidy that up a little bit. Okay. My end behavior, which is my horizontal asymptote, I'm going to compare degrees, which they equal. I'm going to go to that reduced function, and here are my first degree. And you can look at the original one. I just like the, and it's going to be y equals their leading coefficients, which are both 1. And so it's y. And that matches up with all 3 of my points too, right? If it was y equals 0, I'd be a little bit worried. Okay, the next thing that I'm going to do is determine, does my graph, like obviously it's going to come up here, but as it's going through here and it jumps a hole, is it going to, as it gets closer, is it going to cross this horizontal? Because it can cross it, and is it going to approach it up top? Or is it going to stay below it and approach it below? So how do we do that? Well, we test to see if these two lines intersect. So what lines I have? Y equals 1. And then I also have y is equal to my reduced form, x plus 2 over x minus 3. And I want to see, do these two functions cross or touch each other? So I'm going to solve. Always multiply by the denominator. And I'm going to work, and I get 1 times x minus 3 is x minus 3, x plus 2 on the other once that reduces. Subtract my x's, and I get negative 3 is equal to 2. Nope, no solution, no crossing. All right, so now I know it just stays underneath, which it usually does. And I know this is going to do this, right? And then you could say, is this symmetric? You could look at your graph. Somebody said, can I just do all of this and then determine my symmetry? You can. It's not symmetric across the y-axis, and it doesn't even go through the origin, so it wouldn't have odd symmetry, but you'd still need to show it, right? Still need to go. And I don't care if you use the reduced function. So f of negative x, your life a little bit easier. When I plug in negative x, that x plus 2, the x is an odd, so it stays negative or switches sides. Same thing with the bottom, constants never change, no symmetry. Okay, and that's how you graph a rational. So I will go over all of these real quick. I'm just going to scroll through just in case if you wanted to skip all my talking and not have to like skip me. At the very end, I'm just going to scroll back through and you can look at all the answers so you can check your answer. Maybe I'll zoom in a little bit. And here's the next one. And here's the next one. And here's the next one. I think this is the first one we started off with. Yep. Okay. So I will see you on Thursday, Friday.